In this video, we will introduce the current prototype of Envision's version control support. Envision shows programs in a flexible graphical interface and allows for rich information to be embedded directly in the program's source. Providing version control for such information-rich sources is challenging. First, it is desirable to interoperate with established version control systems such as Git in order to support existing development workflows and tools. However, the text-based version control systems used by developers cannot be used directly for Envision's rich sources. And second, we would like to improve the understanding of code changes compared to existing systems. To achieve this, a version control system would have to understand the structure of Envision's rich sources. Let's see how Envision stores programs on disk. Here is a fragment of an Envision source file. Envision sources are direct encoding of the tree structure, which is used to represent programs and other artifacts such as rich comments. Here you can see a method which returns a result and has one argument. You can also see some metadata, for example, a method's position and the visual grid of its parent class. Each line represents exactly one tree node, and all lines have the same format. First is the node's label. Within the parent node, the label is a unique name by which the parent can identify each child node. After the label is the node's type. There is no limit on the use types, and Envision supports extending the system with new types. Third comes the node's 128-bit universally unique identifier. It allows us to uniquely identify a node and precisely track its evolution. Next is the ID of the parent node. And finally, there is an optional value which leaf nodes may have. This format is difficult to read directly, and standard text-based version control tools cannot be easily used with it. Even with traditional source code files, current version control tools are not always easy to use. Here is the difference between two consecutive versions of the same file. Notice how the word file name in this comment has been confusingly matched with this variable. Also, it appears that most code on the left has been completely replaced by the code on the right. But in fact, the code was just moved inside the new if statement. The highlighted changes do not accurately reflect how the code was changed and make it difficult to understand its evolution. To provide better tracking of the evolution of code and enable the collaborative development of programs using Envision's rich source files, we designed a dedicated version control mechanism. Our version control system is built on top of Git. This allows a familiar repository model and the usual versioning of non-code assets, which are part of a software project. To support Envision source files, we develop mechanisms to precisely track the evolution of the program's tree at the fine-grained level. In the rest of this video, we will demonstrate Envision's graphical interface for viewing changes between different versions of a program. Let's show the difference between two versions of this small project. We see the commit message, which also contains an automatically generated summary of renamed symbols, and three different contexts where something has changed. Moved code is highlighted in blue. Here, the class A has moved from one package to another. Modified code is highlighted in yellow. Here, we have changed the value of the fixed variable. Notice how this change was detected even though the code has moved. Deleted code is highlighted in red. Some elements of the deleted class B have been moved to a class C, which is highlighted in green to indicate that it is new code. If we want to reduce the number of visual indicators, we can hide the highlights of renamed variables and only see renamings in the automatic summary. Next, let's see how changes can be put in a broader context using a code map. In this project, we will invoke a variant of the diff command that highlights what has changed on a global project map instead of opening a separate view. All changes are highlighted and scaled so that they are clearly visible. To see the context for a specific change, we can zoom in on it as much as we need. For example, here a method called clear was inserted into the node class. And here an extra statement was added to a method. Finally, we will show you how we can explore the evolution of a single program element. Here is another small test project. Let's see the evolution history of class vehicle. This view shows a horizontal strip of different versions of the class from older to newer. In the first commit, the class was added. Originally, it was called car. Then the start method was renamed and another method was added. The next commit moves a method to the class engine. The commit afterwards only includes a renaming, which appears in the automatic summary. The class was renamed to vehicle. To reduce clutter, no code is shown. The following commit introduces new code, and the last commit makes some additional changes. As you can see, Envision's graphical interface precisely displays changes on a fine-grained level, making it easy to compare versions of the code and explore its evolution. Our work on Envision's version control system is still ongoing. For more information, check out our webpage.